Okay, let's. So I'm going to share the screen now if it works. No, that's the wrong one. That's the right one. Share. Now you should be seeing
Yeah, we can see it.
my presentation, phosphate in the Parrot catchment.
Yep.
I wonder if I can shift it so that. All right, I've got two screens. Oh, that's better. I'm going to shift all you people from the right-hand side to the left. Okay, that is a photograph of a Somerset moor. It's only 5 meters above sea level. It's not like the conventional moors, which are high up. The Somerset moors are very low. This is West Sedgemoor. I've just put it there as an introductory slide, just to show you that I'm not working alone in this phosphate issue. There's other people are working with it, including a couple of universities. So it's quite a large issue. But there is West Sedgemoor, the biggest of the moors. It's a Ramsar site in itself. Next slide. This is a little bit about me. And what I want to do is to show you these little footmarks. Do you know what these are? Anybody?
Looks like a bird.
No. That is the foreprint of a water vole.
Ah.
And I'm putting it in because when I was a child in Yorkshire, as soon as we approached the stream, our local stream, there was plop, 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 as all the water voles jumped in and swam away. These days it's rare, and this one is in the mud next to where I have been taking samples in the River Parrot for the last 2 years. I just want to mention this last issue here. I guided Martock neighbourhood plan through to fruition, and within a couple of weeks it was declared out of date. That's the official planning speak for you don't have to take any notice of it. And the reason was that South Somerset could no longer show a 5-year housing land supply because they said of the phosphate issue. And I thought, well, what on earth is this issue that I've wasted 3 years of my life only to produce a plan that is now out of date. So that's what started me off looking at the phosphate issue in this area. Can I do a quick skip through 3 slides, which are basic science actually, but important. Phosphate goes round and round in nature. Like everything else, it's recycled. But I want to look at this because phosphate is different from all the other things like carbon and carbon cycle and nitrogen cycle and so on, in that the phosphate, the reserve of phosphate is stuck in the soil. And I mean stuck because phosphates are extremely insoluble, particularly aluminium phosphate, which you get a lot of on the Somerset Levels because it's clay and clay contains a lot of aluminium. So phosphate tends to stick hard to soil. It doesn't get washed out easily. But otherwise it does recycle. Next one, which I think is actually much more important than probably the most important issue here, in that oxygen is soluble in water, but it's much more soluble in cold water at 0 temperature, much more soluble than at the summer temperature here. You see, so that as the water gets warmer, oxygen diffuses out of the water, and by the time we get to about here, anything living in our waters is having a bit of trouble. The oxygen levels in the waters tend to be replaced by plants growing in the water and photosynthesizing below the surface of the water and replacing the oxygen all the time. So water organisms find it difficult to survive as the water warms, and they need help of these underwater plants. Anybody know Starhead?
Yes.
It's a very fine, so where the landscape garden movement started, and I'm a garden guide in Starhead, and I took this photograph in July 2018. This is the main lake. It looks like a cricket pitch. And this is what happens when things get out of control. There's a lot of nutrient in the water. This blanket algae grows, covers the surface of the water. No light can get in. And so you can't get any photosynthesis under the water. The water gradually suffers from oxygen starvation and things begin to die. It's made worse when the alga dies because that uses up more oxygen in decomposing, and you get this is a process called eutrophication. Basically, after a while, Starhead Lake, after a couple of weeks like this, it begins to really stink. So that's what eutrophication is, and that's what that is the worry about what's happening to the Somerset Levels. And you get this kind of thing. Took this photograph a couple of years ago. It's pronounced Rhine, R-H-Y-N-E, not Rhine. Rhine in Somerset. I think it's Rhine in Wales or something like that. This is West Sedgemoor. It's fed by local streams. The water flows around, but the problem is that there's very little flow happening because the water now is pumped out of the moor, and in a hot weather there isn't any water left to pump out. But water still gradually comes in from streams nearby, evaporates, and any phosphate then gets concentrated in the water. So this is what happens on a hot year. This is the drought year of summer 22. And down here, these are all thousands of water snails upside down. They've come to the surface to try and get a gasp of oxygen from the air, and they come up with their foot to the surface and breathe in that way. That's a sign of really stressed Somerset Levels. So let's go to the main issue now. The long-term decline on the Somerset Levels, which are UN sites, Ramsar sites, it was declared illegal in, I think, about 2016 by the Supreme Court, which was then the European Court, because of the ecological state. The countries that had such Ramsar sites in Europe, and we're not the only one, Netherlands also has some, were letting them decline and weren't doing anything about it. And it was felt that the high levels of phosphate throughout the levels were the main problem. And so nutrient neutrality programs had therefore by law to be included with all future planning. So if you wanted to build a house, you had to make sure that it was phosphate neutral. This was implemented in Somerset based on two assumptions. One used the Sagis model for modeling where phosphate goes in and out of a system. And this is a desktop model, and they use statistics in DEFRA of the number of cattle in the area, the feed that is going in, the milk that's coming out, the cheese that's coming out, the amount of urine that's coming out, and so they come up with a model that tries to predict where the phosphate is coming from and where it is going to. And basically, they said it was about 50-50 sewage works and agriculture. The problem with models, desktop models, is as they always say, models are always wrong, but sometimes useful. and this one I think is particularly wrong, and I'll come to why later. Now the second assumption that was made was that the phosphate is delivered to these Somerset Levels and moors through the River Parrett and its main tributaries, the Tone, the Isle, and the Yeo. That has not been true for 700 years, but it's still assumed to be true. So Somerset introduced a nutrient offsetting program which aimed to make all its new buildings nutrient neutral throughout their lifetime. I don't want to go into the details of that because it's much more interesting to talk about phosphate rather than local politics. But let's look at this map. I'm sorry it's a bit blurred. It's actually copied from a document. Here is Somerset. Here is the catchment area of the main rivers. The River Parrett starts down here and goes up there. This is the first two Ramsar sites that it comes to. Martock is about where the cursor is now. And then it flows out to the sea in Bridgewater Bay up here. Now, important thing is that West Sedgemoor, which is this Ramsar site here, is 5 meters above sea level. Here's sea level. There's a tidal range of 12 meters there, 10 to 12 meters. So at high tide, West Sedgemoor is slightly below sea level. So here is 30 kilometers or so of river that it's got to go down, and it can only go out at at low tide. So that is how the Somerset Levels and moors started as wetlands, because essentially they're all pretty well at sea level. Here is Langport, which is a lovely town in the middle of the Levels. Langport says it all. It was a port. At high tide, you could get quite big ships from Wales up here, up the river to Langport. In fact, you could get them as far as here in Roman times. So it's all very low-lying, and at high tide, you can move ships up and down here.
Sorry, Andrew, can I just quickly interrupt? Do you get
Yes.
salt water then?
No, you don't. It's interesting. I've often wondered about that, but you don't. The salt water tends to to stop here. What happens is the tide stops or slows down and then stops the outward flow of the rivers. You don't get salt water until you're about here.
Right.
So it's sort of brackish up here.
Right.
But then in the 13th century, the monks at Glastonbury decided that this was a silly waste of useful agricultural land, and so they decided to straighten out the River Parrett between two levees that is about 3 or 4 meters high, and then at high tide, the river just flowed back up between these two levees and didn't flow out into the levels. And at low tide, they could open up little holes in the side of this to let out the water from the levels and moors back into the river, so that it could all get out into there. And it's been like that pretty well now since the 13th or 14th century. The only difference is that we don't open up the sluices in the sides of the river, although they're still there. We pump it out. It's pumped out all the time. So when too much water comes down from the little hills around the levels, it's just pumped up into the river and it goes out to sea. So that's where we are now. Lots of people have been very concerned about the decline in the state of the levels, and lots of people around here help with things like dragonfly counts and bird counts and so on. Dragonflies, I have a friend who's been counting dragonflies for 20 years. 20 years ago, he would typically see over 100 in a couple of hours in the morning. He now typically sees 10 if he's lucky. It does vary from day to day, but last year was particularly bad.
Can I ask a question, Andrew?
Yes.
So when they're pumping the water into the Parrot, does it depend on the state of the tide?
No. Well, yes and no. And it's a problem in that when the tide is high and when the rivers are high, they tend not to pump any more water into the main rivers. And I'll show you a little bit more about that. That's happening as we speak. At the moment, the whole of the Levels is one huge lake, because they're not pumping out water out into the river because there's no space in the river.
Right.
So we get floods, but we don't get floods from the rivers coming down from here. We get floods from water that's local, by and large.
Fascinating.
Well, let's go on to, this is the main bit of research that I've been doing at the suggestion of English Nature, actually. I'm colorblind. This is red, is it?
Yes.
And that's green?
Yes.
And that's blue?
Yes.
Okay, let's look at the blue. This is the phosphate concentration during a summer, during a winter, during last summer, during this winter, up till yesterday. Oh, pretty well. That's normal. Phosphate tends to be at a higher concentration in summer because there's a lot more phosphate going around the phosphate cycle, so that there's a general, there's more of it around in the water.
Can I just ask what the concentration of the phosphate is?
It's the concentration one is here, which phosphate. So this is below 1 part per million.
Right.
But
I've just measured one of our rivers and got 200 parts per billion.
yeah,
You're in parts per million there.
yes. Important to know exactly what you're measuring. Are you measuring phosphate, or are you measuring phosphorus, like English Nature and the Environment Agency do these days? If you're like me, a citizen scientist, so-called, you'll be measuring phosphate, because it's done with American instruments, and the Americans measure phosphate, they don't measure phosphorus. So
it's phosphate.
Yeah, okay.
It's just done with a dipstick.
Yeah, yes. Okay, yes, I know, yes. Yeah. And yours is parts per billion, and you'll be doing 200 parts per billion, 300, 500 parts per billion, won't you?
Yes.
Yeah. Well, this is parts per million. You divide by 3. Divide by three zeros.
Yeah.
Knock 2 zeros, 3 zeros off. Yes. So it's less than 1. Notice that this is pretty well. It doesn't move much. It just goes roughly up and then down. But if we now look at the river flow, this is done at the Chisleborough Environmental Agency station, where they measure river flow and they publish it online every 15 minutes. So this is the river flow, and during the winter we get very high flows. This is the up here to more than 10 times normal, in fact up to 50 times normal occasionally, and we're quite high at the moment down here. Now, this is concentration, which is the amount of phosphate per cubic meter, if you want. It doesn't tell you the actual amount of phosphate flowing down the river in any given time, like in a day. So in order to get the phosphate flow down the river, you multiply the concentration by the river flow. And so the amount of phosphate in the river is this one. The phosphate flow down the river is very low until you get, suddenly the river starts flowing, and then you get a much greater amount of phosphate flowing down. So the question is, where on earth does that phosphate come from? If here you've got, what, 4 times as much phosphate as you had a few weeks ago, where's it coming from? So that was the question I've been trying to answer. I assumed that this level here, which is during summer and is pretty constant, that comes from the sewage works upstream. We've got 2 major and several minor sewage works feeding the river. But then suddenly in winter, you get a vast amount of phosphate. And in some cases, a huge amount of phosphate up there. So the question was, where does it come from? I tested some tributaries, and they didn't show, the tributaries always showed less phosphate, lower concentration of phosphate than the river itself. So the phosphate, this amount of missing phosphate wasn't coming from tributaries. And the answer is, it's coming from the sediment in the river. There's a lot of phosphate tied up with the sediment in the river. When you stir it up, it releases it into the water. And that happens over winter. I've
Sorry.
checked all. Yeah.
Andrew, I'm so sorry. I'm lost. Can you just explain something to me? Is that green line, the flow, in parts per million still, or is it a different unit?
This is phosphate amount, and it's on this scale, and this is in kilograms per hour. So the amount flowing past in kilograms per hour. So up here
that's a river flow. That's a river flow in kilograms.
This is the river flow. This is the river flow in meters per second, cubic meters per second.
Yes.
This is the phosphate flow in kilograms per hour.
Oh, kilograms per hour.
Yeah.
Okay, so it's unrelated. It's unrelated then to the concentration.
Well, it is related to that's the odd thing, isn't it?
Yeah.
It seems to be pretty well unrelated. I mean, that's a little bit related. Do you see there? It goes up a little bit here, but it goes up at a huge. So this is the odd thing that struck me when I first found it as odd, but it didn't strike the scientists at Lancaster University as odd. They said, yeah, it's just what you expect. If you put a lot of water down the river, it stirs the river up, it stirs the sediment up, and it looks like almost like milk down here because of the clay. It gets very turbid. And what you're doing is you're releasing a lot of phosphate from the sediment to the river. And this phosphate in the sediment has built up over years from the sewage works. In fact, Lancaster tell me, it's been building up for a century in most rivers and in fields. So we're getting a gradual buildup of phosphate over time, accelerated greatly in the last 30, 40 years. And they are particularly concerned about this because it's not only in the riverbank sediment, it's in the soil everywhere. So I can't think if there's anything more I want to say about this, except that I've got a colleague now doing the same kind of graph further downstream in Langport, where they've just opened a new environmental agency station. But it's useful, is that it gives us, I think, a good picture of actually what's happening in the river. What we're now looking for, of course, is that the Wessex water over the last 3 or 4 months have stopped the phosphate pretty well coming out of 3 of the sewage works in the Parrot. And what we're hoping to see is that gradually this level is going to get less and less. But the thing is, how long will it take to get down to almost zero? Will it be a year or 2, or will it be a century? Much depends on how much phosphate there is hanging around in the sediment, I suspect. So this is going to be quite an interesting investigation.
Andrew, what's a desirable level of phosphate concentration?
About 1/10 of this.
Wow.
Well,
0.1,
Yeah,
0.2.
0.1.
and is it easy to remove the phosphate from the sediment? Can you filter the sediment?
No, it's very firmly bound. It's insoluble pretty well most of the time. But if you put a lot of fresh water into the river, then some of that bound phosphate will come out into and be soluble phosphate in the river. This is very, very little phosphate. Even up here, you'd in in a liter of this river water, to get that concentration, you've just got to it's a bit like a sugar crystal's worth. It's very, very insoluble.
Woo.
No, but so maybe I'm not understanding. But if you said that when the flow's high, then the phosphate comes out of the sediment. So you've got the phosphate
Yes, it
in the
does.
sediment, whether it's
Yeah.
soluble or not. So I was
Yeah,
wondering,
it's
if it's possible to dig up the sediment in a patch, say, and put it in a bucket and somehow filter out the phosphates.
no. The answer is no. It's
Go on.
interesting that it's a thing called a chemical equilibrium. I won't bore you with that, Tristram, but I can send you some references, some reading references, if you like.
Okay,
Basically, it's
No,
not
okay.
it's not within our control. It is a
Right.
natural equilibrium between the concentration of the phosphate in the sediment and the concentration of phosphate in the water, which tends to remain a constant ratio no matter what you do.
Right.
So it's a chemical equilibrium
Okay.
between the two.
Andrew, what does this do to the sea where all this lot is arriving?
I was hoping you weren't going to ask me that question, Graham, so I'm going to ignore it.
You politician, you.
I have no idea, but I suspect that this is part of the wider phosphate cycle, that it'll go into sediment in the sea, and over long periods of time that'll be in phosphate rock and so on. I just don't know that half of it at all.
Would it be worth measuring the turbidity?
I do measure the turbidity. Yes, it is worth it.
But by comparing the turbidity and the amount of phosphate, you should be able to tell, because I presume you're gradually washing out the phosphate.
Yeah. Yes,
So
you
if you
are.
compare the turbidity, which probably won't change, with the level of phosphate, then you should see that going down.
No, actually, the turbidity does change. It's turbid on these times, and it's actually off the scale of my turbidity meter, but it very quickly settles down, and the Parrot water is beautifully clear most of the time. And so it's you can't get much phosphate out by somehow removing the sediment. It would be very difficult to remove anyway because it's very, very fine. It's like milk. It's like milk almost. You can't really filter it. It blocks up all the filters, as Wessex water knows.
Just out of interest, does anyone measure the phosphate upstream from, say, the Severn Bore? Because is that carrying phosphate that is picked up from the Bristol Channel?
I don't know. It requires people like me to do this because the Environment Agency can't afford to do it anymore.
Yeah.
You see, they used to do it until 2018. They used to do it once a month. But in order to do this, to get a decent set of results that you can use, you have to do it daily, or even every 15 minutes.
So we depend upon the citizen scientists.
Yeah, and this process that I'm using is difficult to automate. So it requires people. Let's go on a little bit. Here's the Parrot. This is where I measure it. This is upstream, looking upstream. That's all the Parrot is. It's less than 1 cubic meter per second flowing out of this under here. Here I'm standing on the bridge parapet to take this photograph. That's normal level. Basically, the summer load is about 40 kilograms a day, as I mentioned, and it's due to sewage plants. very little coming in from agriculture. That's the assumption.
But that's changed now because of Wessex Water's updates or improvement.
And that, it's gone down to 32 at the last time I did it when it was a low flow. But we've had very high flows for most of the time over the last month, you see. So I haven't had much of an This is an interesting one we're going to follow, and Wessex Water is particularly interested in what's going to happen to this each day. Another thing is that if farmers obey the rules for farming near water, and most of the farmers do around us, then you don't see phosphate in the little tributaries. I've sampled several of they're very deep reens, and there's a little bit of water at the bottom. Whenever I sample that little bit of water, I seldom find phosphate. Basically, phosphate, as soon as it goes into the clay here, in the top 2 or 3 inches, it removes the phosphate. So anything that's coming out into the reens and into the river is pretty clean.
Sorry, what removes the phosphate?
The soil.
The soil.
The aluminium in the clay.
Right.
Aluminium and iron removes phosphate very quickly. I think most of it is removed in the top 2 or 3 inches. But the land drains that the farmers put in around here are usually about 50 centimeters down. And whenever I've tested the output of a land drain, I haven't found any phosphate at all.
When you say removed, do you mean it's reacted with into something benign?
It's combined with aluminium in the soil, and you get aluminium phosphate, or crystals which contain aluminium phosphate, soils which contain aluminium phosphate, and the phosphate stays there.
But it doesn't matter. If that gets in the water, it doesn't matter. It's not phosphate anymore.
It doesn't get into the river. But I'll come to a little bit more in a moment, Tristram, about where it does go.
Thank you.
So DEFRA rules work well. Most farmers around here obey the DEFRA rules. A few don't. And since we started doing this work, the Environment Agency has been able to use what we've been doing to successfully prosecute 2 farmers.
Right.
We haven't given them details. We've just told them what we're doing, and we think and pointing out where there's a problem. They know. As soon as you give them a reference, they know which farm to go and visit. And so they go and visit. The trouble is that they don't prosecute them for pollution. They tell them what they have to do to stop the pollution, and then they go on an unannounced visit to the farm a few weeks later. And if they haven't done it, it's quite easy to prosecute. But you don't prosecute for pollution, you prosecute for disobeying the Environment Agency. And so you don't fine them 100,000, you fine them for 10,000. And that's probably a quite cheap way of disposing of slurry, being fined £10,000 per 5 years or so if you've got 3,000 cows. So some of these farmers are now prosecuted regularly. But there are very few of them, and it's a bit embarrassing for the ones that do value what they're doing and value the land. I took this photograph last night. It's a pond, and ponds are usually very phosphate free. This is a flood alleviation pond very close to us. It's actually part of a little nature reserve which we're developing. The land belongs to Highways England, or National Highways, I think it's called now. And we've taken it over and run it for them as a little nature reserve. And this pond, even though it's fed from fairly phosphate-rich streams, after a couple of days of flowing into here, there's very little sign of phosphate. So one useful way of removing phosphate is good quality flood alleviation schemes. Another picture here. This is taken last week, and this is the River Parrot flowing down here to Langport. This is from the bridge at a place called Muchelney, which is a place that gets flooded regularly. And in the last floods, the big floods of 2013, it was visited by David Cameron in a brand new pair of clean green wellies, everybody noticed. And then it was visited again about a week later by Prince Charles in a very dirty pair of green wellies. But the point about this is that it looks as though it's in flood. In fact, it's maintained at this high level artificially. This is the flooding area. This is in flood, and this water has a much higher concentration of phosphate than this water, probably twice as much. The reason is that this is the local water. The flood is running over the local fields. It's picking up phosphate from the fields, which has been put in there for 100 years. So in your top few inches of field, you've got quite a lot of phosphate. And so that picks up quite a lot from there. So this phosphate concentration is double that phosphate concentration. It looks like, if you look at the levels at the moment and look down on it, it looks like one mass of water everywhere. But in fact, it's different bits of water that are pretty well independent of each other. As far as possible, and that's manipulated by the Environment Agency operating the sluices very cleverly, I think. So these are the two issues here: the additional phosphate due to legacy phosphate in river sediments, and a lot of that phosphate washed out of the soil goes into here. Question is, what happens to this when it is pumped out? And that's an interesting research question. Does flooding of the levels reduce the concentration of the phosphate in the Somerset Levels, or does it increase it? At the moment, my feeling is that it reduces it, that a lot of this will go out when it's pumped out, and that will take a lot of phosphate away. But how long that will take to substantially reduce the amount of phosphate around in the levels, nobody really knows.
Andrew, can I just ask a question?
Yeah.
On that water to the right is you're saying is the flood prevention. So doesn't that act like a pond? And you said in a few slides before that in a pond the phosphate settles out.
Yeah, that's a question that I'm trying to study. When it comes out, when that water accumulates, because there's a pump down here, and they've stopped pumping it out. You see, as it accumulates, it takes phosphate from the top layer of the grassland there. Yeah. That turns out to be pretty high. Now, as it drains away, either naturally or artificially, what we find is that the phosphate that's left in the drainage channels within this area is much lower. And in fact, almost in this particular one, which is called Wetmore, when I test the Wetmore reens just after the phosphators, this floods have gone, I find very little in the reens. Not quite sure why I should find very little in the reens, but I do. So there are issues here which seem to me certainly not clear at the moment. And you know, I'm not the only person that's concerned.
You said on the ponds that the ponds, when they've have new water put in, very high phosphates, and then after a day or two, it's all clear.
Well, that, you see, the pond is a permanent thing. This is
Yeah.
a flood water and it will go
Yeah.
down. It'll soak in. The pond stays there,
Right.
and the phosphate in the pond is taken up by the weed that's growing around the edges and the weed that's growing in the pond and so on. That's oxygenating the pond and everything. So if you've got a healthy
not-
pond, then it removes phosphate.
Okay.
This isn't a pond.
Right.
This is a flood.
Yeah.
Last one. Well, there's a few research questions. I'm going to ignore those for a moment because I like this photograph. Just behind me, up in the hills at where we've got a hill fort behind me, and behind that we've got a Motte and Bailey castle that dates from the 11th century, isn't it? About 1070, 1060 something. And at the top of the Motte and Bailey castle, this is the view down the River Parrett all the way to the sea. And the sea is just down there. And on a really good day, with a pair of binoculars, you can see Big Carl. Do you know who Big Carl is? It's the biggest mobile crane in the world. It can lift 5,000 tons, around a radius of 40 meters, and it can lift it up as high as 250 meters, a quarter of a kilometer.
Wow.
And it's building Sizewell C.
And it's building Sizewell C.
Well, Hinkley C.
That's Hinkley
Hinkley,
C.
sorry.
Hinkley C, yeah. And you can see this huge crane and a few others round about it through binoculars 30 odd kilometers away from the top of our little Motte and Bailey castle. But here are a list of a few research questions that have been occurring to both me and other people who are looking into this, about how we should sort the levels problem out. My feeling is that the key thing is this one. Is the problem, the levels problem, a phosphate problem, or is it a global warming problem? And my feeling is that after working on this for 2 years, I'm pretty sure that this is a global warming problem, and that the phosphate is just an exacerbating factor which makes it a bit worse and a really bad year. Because we've just had a year where we've had rain pretty well through the summer, and we haven't had the same problem in the rains in the levels as we had the previous year when we had the drought. So my feeling is that we're not looking at a relatively simple phosphate issue. We're looking at a much more serious and complex issue, which is global warming. And I don't know how you help out the Somerset Levels out of that. But we're trying to think of things like paludiculture. What can you grow in the Somerset Levels which will remove phosphate better than the cattle that are there growing at the moment? One thing that we're investigating is, or that is being investigated, is growing willow, withies, traditional crop in the Somerset Levels. It's now coming back into fashion and into use, and you can either make attractive things out of it. It can be a high-end economic crop, or you can chip it and burn it in power stations. So things are happening. Things are having ideas are coming forward and being tested, but we're in early stages. Okay, that's pretty well everything. Any questions? Shall I share? Pass the screen over, Graham?
Sure, by all means. But Andrew, thank you so much. I found that utterly fascinating. That was a really very interesting presentation largely because it upsets pre-considered,
Yeah.
beliefs. I do have a question though. There's reverting to the difference between a pond and a lake in terms of how much cleaning it can do. Since all of those fields are covered in grass, and the grass continues to thrive underwater because when the water disappears, it's very much alive. Is it not removing some of the phosphate? And that sort of leads to a second question, which is those high levels of phosphate in the soil, do they assist in the growth of what the crops are in the field?
I think the answer to the second one is certainly yes. But how much phosphate, it's a good nutrient. And then, of course, they will harvest it as a hay crop. Not a particularly good hay crop because it's not the high yielding ryegrass that is now grown for hay, but the farmers do harvest it, and there are farmers on the levels, and an increasing number now, I think, who are working at that sort of high value end of livestock rearing with particular, with belted Galloway cattle and so on, and making cheeses and things like that at sort of at the high end. And that seems to be a sustainable farming. Whereas around West Sedgemoor, there are several dairies, each of which with several thousand head of cattle, and they have an awful lot of slurry to get rid of. And that is creating the problem, particularly in a year like this, because they have to get rid of their slurry in the next 2 days. Because at the end of February, the season for spreading slurry, liquid slurry, is at an end. And you can't spread liquid slurry on saturated clay. You're not allowed to do it. So it's a serious problem.
And does the phosphorus go into, or the phosphate go into the food chain through the cows and the cheese and so forth?
Yes. The question is, where does it, whether it goes outside the levels or not. What is happening at the moment is that, or outside the levels catchment, the larger area, and what's happening now is that an increasing number of fields, increasing acreage is being put over to maize, and that is being fed by the solids left in the slurry pit in the more distant fields from the farm, or by slurry applied between October and February in the fields that are near these large farms. Again, if these farms, technically they should be phosphate neutral, and they do advertise themselves as phosphate neutral because the phosphate that the cattle make, which is all collected in barns, is put on the fields, which then is converted into maize. The problem is what happens with accidents, or if if you're not if you don't obey the farming for water rules that DEFRA have laid down.
Utterly fascinating, very intriguing. Anybody else got any questions, please?
Yeah, I just wanted to, again, just to clarify my understanding. You said that the sewage works are now much better at filtering out the phosphates before they get into the watercourse. So if the farmers in general are obeying the rules, and that's not what the problem is, haven't we solved the problem just by making the sewage treatment much more effective at getting rid of the phosphate at that stage?
Hopefully, that's why people are taking notice of the results that I'm taking now, because Wessex Water are very interested in this. They measure the phosphate that's coming out of their sewage works, and that's very little now. And I've measured that as well, and it's very little. But by 50 to 100 meters downstream, I can detect very little change because, of course, the cleaner water that's coming out of the sewage works is quickly taking up phosphate from the riverbanks and the sediment, and we're back to normal.
Well, you're not, because surely that'll wash through over a few years.
Exactly. How few is few? That's what we're trying. That's what we're
100
working
or
on.
more. Yes.
That's what we're working on. My guess is that we'll see quite a big difference in the first year, but that will tail off over time, but it won't get down to almost zero for decades, maybe even centuries. I don't know.
Right.
This is chemistry, phosphate chemistry. It's awkward
But
chemistry.
I would have thought if it's a sort of chemical equilibrium, it would be a sort of logarithmic decay.
Yeah, I was going to mention that it should be an exponential decay, and there is one sewage works which is at a place called South Petherton here, which has been now amended, put right about 6 months ago, and that's what I think we're seeing. But the trouble is, I haven't been able to get out to measure it because we've had such an odd season in the last 2 months. I haven't been doing my usual measuring of all the way along the Parrot in a normal day or a normal week, because we haven't had a normal week.
Yeah. And can I just ask what the water treatment works are doing to remove the phosphate?
Yeah, it's iron sulfate they're putting in there. They're passing it
And
through.
that chelates the phosphate.
That's right. It chelates the phosphate, and they tell me that it comes out with they get a chemical which, with very little treatment, can be converted back into fertilizer. The trouble is that this country no longer produces its own iron sulfate because our iron and steel industry has declined so much now that they have to import this iron sulfate from Poland.
Oh.
So
what about sprinkling iron sulfate on the river?
yeah, there's all kinds of things like that. There's a little company near us that has developed, so I understand, some sort of thing that you can put in a small stream and remove the phosphate from it as the stream flows through it. And that sounds like a nice, sustainable process. But that's in early days, and they won't tell me any of the details because it's all secret.
Right.
Very interesting circular thing. I mean, years ago when I was working in a nuclear submarine, we had iron sulfate exchange devices which were taking the iron out of the water.
Yeah.
And here you got a new little company in Somerset developing something to take the sulfate out of the water.
Yeah.
Fascinating.
Yeah.
Well, I did find that fascinating, Andrew. Thank you very much indeed for the time and trouble. Really enjoyed it.
Yeah, wonderful.
Well, thank you for inviting me.
You've obviously put a lot of effort into it. I'm impressed.
Well, it's not specifically for this presentation. It's been my hobby for 2 years now.
But how many other citizen scientists are there around the country?
There are lots.
Right.
I mean, I suspect that Stuart is doing the same kind of thing as many people are doing down in the West Country, called West Country Rivers, and there must be about probably several hundred doing it in West Country Rivers, and I'm one of those.
Brilliant.
Mm-hmm.
Well, more power to you, and thank you again. And I look forward to seeing everyone next week when I could tell you what we're going to see, but I've forgotten.
Okay.
Take care, everyone, and thank you again.
Thank you, Andrew.
Yeah.
Okay.
Thanks, Andrew.
Okay. Bye-bye.